Hello and welcome at our sixth meeting over science news. This week's story comes from my realization that despite many recent events grabbing our attention, there remains one global issue that's an ever-present concern. And of course, this is the issue of global warming and climate change. One of the things that has reminded me of this issue this week is a video from NASA, part of which is shown over here, which shows how the global average temperatures has changed over the years from the year 1800 all the way to 2021, showing us the rapid increase in average global temperatures, especially in the recent years. We of course know that this change in global temperatures and changes in global climate are linked to carbon dioxide levels rising rapidly in the atmosphere, especially in modern era after the start of Industrial Revolution in 1750, as we can see over here. And unfortunately, most of our modern lives and lifestyles is linked to activities that consume fossil fuels and therefore lead to emissions of carbon dioxide together with other pollutants, but carbon dioxide being the main factor in terms of global warming and climate change. And of course, us as human beings, having realized this issue, we are now actively trying to find ways of changing the way we conduct ourselves so that the amount of carbon dioxide that we emit into the atmosphere can be decreased or eliminated. And we are not only trying to adjust our lives and our industry so that we emit smaller amounts of carbon dioxide, we are also trying to look for ways of removing carbon dioxide from the atmosphere to lower its content there, and then either store or utilize this carbon dioxide. And a story in the chemical and engineering news from this week is looking at one of these technologies called direct air capture, which is a technology by which carbon dioxide is removed directly from the air. In this article, a factory or a plant called Orca, which is operated by the company Climeworks, is described. This company is located in Iceland. The technology behind this plant is a use of a filter through which ambient air can pass under ambient conditions, and which will selectively remove carbon dioxide from this air and store it inside of the filter material, then releasing air without carbon dioxide. Once the filter gets filled by this operation with carbon dioxide then can be removed by heating the filter to 100 degrees Celsius, and this concentrated carbon dioxide can be used, or in this case stored. In the case of this particular facility, the captured carbon dioxide is converted to carbonate materials, which are then stored underground. In other approaches, the carbon dioxide removed in a similar way from the air can be used to synthesize more complex molecules or fuels that then can be used instead of fossil fuels extracted from the ground. While the technology of direct air capture looks promising, there are a number of issues that need to be resolved before it can be deployed on scale. As we can see here, one of the key issues with this technology is its rather high cost of $300 to $400 per metric ton of carbon dioxide captured, which is much higher than other technologies dealing with reducing the amount of carbon dioxide in the atmosphere. It also needs to compete for sources with technologies that try to limit the amount of carbon dioxide being emitted. Despite these problems, there is no doubt that this technology will be playing part of the role of our efforts in reducing the effects of human activities on the climate and on global temperature. Thank you for coming, and see you again next time.